Let's take this one, 7y minus 5x equals 22. Okay, again, we want it in terms of the y. So first thing we've got to get rid of is this negative 5x. So we go 7y minus 5x plus 5x. We just add the opposite. And then we've got to do it on this side. So you remember me, I want to put the 5x in front. So 5x plus 22. It doesn't matter which side I put it, really. Okay, so then negative 5x plus 5x is 0, so we have 7y equals 5x plus 22. And we want to get rid of the 7, so we divide by 7, and that gives us what we're looking for, y equals. Now, the 7 into the 5, we don't want a decimal, so we'll just leave it as the fraction. 5 divided by 7 is the same as 5/7. So we have 5/7 x plus 22/7. So we have to divide it into both of them. And I know it looks ugly, but that's putting it in y equals form. Okay, and actually I'll accept it like this, except you gotta get rid of those 7s. You know, we could have it y equals, for now, 5x plus 22 over 7. Inequalities. Okay, so what are inequalities? Well, that's when one thing is bigger than another. So, so we have less than or equal to, greater than or equal to, less than, greater than, less than or equal to, greater than or equal to. And so like 3 is less than 5. And 7 is greater than -3. And 4 is less than 5, but it's also less than or equal to 4, right? It's less than a million. It's less than a lot of things. And then 7 is greater than, 7 then is greater than or equal to 7, and also greater than or equal to 2, and 1, and -1/2, and so on. Now let's talk about an algebraic inequality. So we'll throw in an x. Let's say x is greater than 5. See, so now to graph that x is greater than 5, we need all the x's that are greater than 5. So we have to find 5, which is right here. And we need to indicate that what we're talking about is greater than 5. So if it's greater than, we always use this form, the parentheses, and then we make an arrow in the direction of the numbers. Everything that's greater than 5, but it doesn't include 5. Okay, so let's say we had, so that's x is greater than 5. What if we had x is less than or equal to a -3? Okay, so we find -3. It's right here. Now it's less than or equal to, so we use the bracket. You don't have to make it quite as big as I'm making it, but it's less than. You notice that this part of the bracket is going in the direction. Oh, I did that wrong. Hang on. See, I put it by 4. You're wondering, what the heck is he talking about? Okay, so 3. So it includes 3, and it goes in the direction x is less than or equal to a -3. So it includes -3, and it's everything that's less than. So the arrow indicates everything that's less than -3. See, so when it's and equal to, less than or greater than or equal to, we use a bracket. Like if we had, well, let me write this in here. Okay, this one is x is less than or equal to -3. Okay, so let's do something like, okay, x is greater than or equal to a negative 1. Okay, so negative 1, see where negative 1 is, it's greater than or equal to, I'll use the bracket. Notice I'm going in the other direction. And of course we won't have all three of these on here at the same time, we just have one. So this one is x greater than or equal to negative 1. And then the only one I'm missing is less than. So let's do a less than. X is less than negative 9. I have that space open here. Okay. So less than would be parentheses. It goes in that direction. It's all the numbers less than negative 9. X is less than negative 9. Okay, so what if I want to indicate this in another way? And they have something called interval notation that really matches this thing here that I've just drawn. Okay, so for instance, for x is less than negative 9, that means it goes all the way to negative infinity, whatever that is. So we would make it like this, because negative infinity is not a particular number. We have to put a parenthesis there. Okay, so going from left to right, see, starting down this end and going that way, when we make this interval notation, we go, starts at negative infinity, and then comment, we put where it goes to. It goes to a negative 9, but it doesn't include negative 9, so it would be like that. This one, x is less than or equal to negative 3, again, it starts at negative infinity, and then it goes to negative 3, but this one, it includes negative 3, so it gets the bracket. So you notice how these things match the graphing of it. Okay, up here we have x is greater or equal to negative 1, so we'll use the bracket because it includes negative 1, and then it goes to positive infinity. Of course, positive infinity gets the parentheses because there's no particular number that's positive infinity. Okay, and then the following one is x is greater than 5. So it doesn't include 5. It starts at 5 though, but doesn't include it, and then it goes to positive infinity. Okay, so we'll do one separate here, just in case you got the wrong idea. Okay, so let's say that x is greater than 0. Alright, if x is greater than 0, then it gets a parentheses and an arrow to include everything that's greater than. Then if we did the interval notation for that, we would have that. Notice it replicates what's right above it. It starts at 0, goes to positive infinity. So they call it interval notation because it includes the whole interval. This whole interval, well, going up to infinity, right? So it's a good way to show it. Let's do one more. X is less than or equal to 4. Okay, since it's less than or equal to, it gets the bracket. Arrow points in this direction. Okay, so then if we're going to do the interval notation, we're going to have to include this interval that goes from left to right, so it's going to start way over there at negative infinity, and it's going to go all the way up, and it's going to include this. So negative infinity gets the parentheses, comma, and then we put where it goes to. It goes to 4, and it includes 4, so we'll do that. There you have it. So what I've just taught you is useful when we start working inequalities that are a little bit more complex than just x is greater than 3. Okay, so let's say we've got this equation. 3x minus 4 is equal to a negative 5 plus 2x. That's a plus sign. Okay, so if we're going to solve this, well, we have to decide what side we want our x's on. I guess we want our left, so we'll go over here we're going to go a negative 5x plus 2x minus 2x. And then on this side we'll have 3x minus 2x minus 4. Okay, so on the left we end up with x minus 4 equals a negative 5 plus 0. Right, so we'll just leave the 0 up. Okay, now I'm going to add 4 to both sides, so I have my x alone. So at x minus 4 plus 4 equals a negative 5 plus 4. Okay, so x equals a negative 1. Okay, super. Let's do the same, but let's make this an inequality this time. 3x minus 4 is less than a negative 5 plus 2x. Now notice we're going to do it exactly the same way. Okay, so if we're going to get our x's on the left side, we're going to use the additive property of inequality instead of equality, which is what we used over here. You know, so we'll go 3x minus 2x minus 4 is less than a negative 5 plus 2x minus 2x. So subtracted 2x from both sides. Right? So we get x over here minus 4 is less than a negative 5. Okay, and then we add 4 to both sides. X minus 4 plus 4 is less than a negative 5 plus 4. So when instead of getting x equals negative 1, now we have x is less than negative 1. Okay, there is one really big difference. Outside of that, you know, well, we will solve the inequalities exactly the same way we've been solving equations except for one thing. And that one thing has to do with if we multiply or divide by a negative number. So for instance, if I had 5 is greater than a negative 1, and I multiplied both sides by a negative 1, or divided, doesn't matter. So negative 1 times 5 is greater than a negative 1 times a negative 1. Or is it? This becomes a negative 5, and that becomes 1. So actually negative 5 isn't greater. So whenever we multiply or divide by a negative number, and in inequality, we've got to change the direction of the sign. See, so notice, the sign is switched when we multiply or divide by a negative number. Now I'm going to demonstrate that with the equations we already did. Now watch what happens when I do the exact same inequality, but I'm going to get my x's on the right side instead of the left side, which is going to cause me to have a negative x term. So watch what happens here. So I'm going to subtract 3x. 3x minus 3x minus 4 is less than negative 5 plus, I don't know if I can get it all in here, 2x minus 3x. I did it. Okay, so that becomes 0, and we end up with negative 4 is less than negative 5 minus x. Okay, so I've got my x term on the right side, and I'm going to add 5 to both sides to get rid of this 5. So we've got a negative 4 plus 5 is less than a negative 5 plus 5 minus x. And that gives us a negative x on that side. And on this side we have 1. Okay, so, but I don't want to know what negative x is, I want to know what x is. See, so here I either have to multiply by a negative 1 or divide by negative 1. So let's just, this time we'll divide by a negative 1. Divide by negative 1. Now because I've done that, I have to switch my inequality sign. So now it becomes like this. So it's a negative 1 is greater than x. But if you read it from this direction, you can just switch these around. It's x is less than negative 1. So it's x is less than a negative 1. And that is the same thing as I have right here. X is less than negative 1. See, if I read this from right to left, X is less than, because you know, the smaller part of this arrow thing is pointing towards the X. X is less than negative 1. And this one, X is less than a negative 1. Okay, so you see I get the same answer with the same equation, just putting X on the other side and it makes it negative, but I have to divide and I get the same thing. See, so if you multiply or divide by a negative number, it doesn't have to be negative 1, but any negative number, you know, because sometimes it's not going to be a negative X, it'll be negative 5X or positive or negative 6X or something like that. You'll have to divide by a negative 6 or negative 5, right? Okay, so then you switch the sign. But that's the only difference. Otherwise, they're exactly the same as solving equations. Okay, let's solve this one. Got a negative 7x plus 5x is greater than 3x minus 1. Okay, let's go for getting our x terms on the left side. So gives us negative 7 plus 5x minus 3x is greater than 3x minus 3x. Notice I added a negative 3x or subtracted 3x because I want to get rid of the 3x on the right side. Minus 1. Okay, so that gives me negative 7 plus 2x is greater than a negative 1. Okay, and get rid of the 7. I'm going to add 7. Negative 7 plus 2x is greater than negative 1 plus 7. Okay, so that ends up with 2x is greater than 6. And again, I wouldn't know what 2x is. I want to know what x is, so I divide by 2. Divide by 2. Notice it's positive, so I don't have to change the direction of the sign. That cancels, and I get x is greater than 3. Okay, so our solution, which is actually a set of numbers, is x is greater than 3. So it's a solution set. This is a solution set. The solution set is x is greater than 3. So the next thing to do is to graph it. So let's graph it. So we have to find 3, which is right here. Remember that if it's greater than and doesn't include 3, we use the parentheses, and we draw our arrow. Okay, and so then we want to use interval notation to show this. Okay, so we just replicate this thing. It's this, 3, because x is greater than 3, going from left to right. So it's greater than 3 and includes, so it doesn't include 3, so it's 3 to positive infinity. And then positive infinity gets that. Now there is another type of notation. It's called set builder notation. And actually set builder notation just uses this plus something else. So set builder notation is like this. Same thing. It's actually simpler. Uses braces. It's contained within braces. You know, like set. You know, if we have a set of numbers, we'll put them in braces. Okay, and we look at what it is we're talking about, which is x. So it's x, and then we put a line like this, such that x is greater than 3. See, so it's actually simpler notation. It's just people forget how to use the braces and this such that line. This line here, such that, this, like, we're talking about x, just saying we're talking about x, and this is what x does. X is greater than 3. But we're not going to be testing you on that. But I just thought I would show it to you. It's these three things. You got to know how to solve an equation, solve an inequality, get the answer, right? Graph it. Let me use a different color here. You know, find the answer, graph it, and then do this, the interval notation, which is a lot like the way we graph it now. See, so not so hard, but you need to do a few problems for this to make sense. So I guess I could throw in a couple problems more if you want to have a little more practice. Okay, so we're going to solve it just like we solve equations. And So we look at our equation and simplify both sides. Notice that this side is already simplified, can't simplify it anymore, but this side has a distribution, so we've got to do that first. So we got negative 2x plus, alright, 3 times 4x, and then 3 times the negative 2. So 3 times 4x is 12x. Whoops, change color. 12x, you can hear my wife and son in the background. Minus 6 is greater than 7x minus 3. Okay, still the right side is still simplified. It's the left side. We have to combine the negative 2x plus the 12x, which gives us 10x. 10x minus 6 is greater than 7x minus 3. Okay, so let's put our x terms on the left side, so we'll subtract 7x. So 10x minus 7x minus 6 is greater than 7x minus 7x minus 3. So that gives us 3x minus 6 is greater than negative 3. Okay, so we've got to add 6 to both sides to get rid of this 6 here. 3x minus 6 plus 6 is greater than negative 3 plus 6. We get 3x is greater than 3. Divide by 3, divide by 3, and we get x is greater than 1. Okay, so let's graph x is greater than 1. Okay, let's find 1. Okay, here's 1 right here, greater than 1. And then let's do interval notation. So it starts at 1 but doesn't include 1 and goes to positive infinity. Okay, let's do this one. Okay, and then again, let's just put our x's on the left side. This time I'm going to have a negative. Okay, so we'll go, we're going to have to subtract the 7x. So 7x minus 7x minus 3, and on this side we have 2x minus 7x. So then we get a negative 5x is greater or equal to negative 3. Okay, divide both sides by negative 5 because we want to know what x is. So negative 5, negative 5. Okay, so negative 5 into negative 5 is 1. So we have x, but we've got to change the direction of this sign, is less than or equal to, and negative 3 divided by negative 5 is a positive 3/5. Okay, so we can still graph this. Okay, we have to find out where 3/5 is. It's somewhere between 0 and 1, 3/5. We divide that up into 3 parts. It's, I don't know, it's right about here. So, okay, so now x is less than or equal to, so we've got to do the bracket thing. So let's say that that's 3/5 approximately. So, and then it's everything is less than that. There we have it. Okay, and then our interval notation. Notice on the left side starts at negative infinity, and it's comma, and it goes up to 3/5. And it includes 3/5 because it's less or equal to. And that's it. So as we tramp off through the snow, we say goodbye to formulas and inequalities. So if you need practice, go back over some of these things and redo them. Do them yourself before you watch me do it. Okay, and also go into the review that's in my math lab. That well, actually, I'm going to put this in my math lab too. So go back in and watch the screencast for the chapter 1-2 test, and look at anything that you don't understand. Because I'm not going to have a lot of time to go over this formulas and inequalities. I'm glad you've watched it.